we're continuing our composition of functions. So in example 3, we have a graph, and in this graph you're going to see a g function and an f function. It's important that you can identify which is which, so there'll always be something where you can differentiate between the two. All right, now g of f of 0 says I'm taking f of 0 first. So that was the first thing we wanted to figure out. So f of 0 means I need to look at the f function and see where is x equals 0. So when I look at this, x equals 0 has an output of 0. So that is just f of 0. To find the next part, we do g of whatever that output was. So it happens to be 0 again, but g of 0 means I'm going to go to 0 and look at the g function, which is this one. So that has an output of positive 3. So if you write it out, g of f of 0 would be 3. Now f of g of 1, however, says f of g of 1. And that means g of 1 comes first. So start there, g of 1. Start when x is 1 and find the g function. So if x was 1, g is up here, which is that positive 4. 1, 2, 3, 4. That is going to go into our f function. So f of 4 would mean I'm going to go to when x is 4, 1, 2, 3, 4, and find out where's the f function, which happens to be up here at positive 2. So f of g of 1 is 2. And then the last one actually composes g of g, and that's okay. You can compose upon itself. But I'm going to start when g of negative 2 is, so if x is negative 2, g has an output of positive 1. Since that's going into g again, we're going to find g of 1. So now we look at when x is 1, and it has an output of 4 again. So g of negative 2 has an output of 4. This last part is definitely the trickiest because it's the most abstract, so it might take a little bit of time to figure out what this is looking like, but give me a few examples before you decide that you just can't understand this. All right, so if we're looking at f of x, this is saying capital F of x represents f of g, so it represents the composition of two functions. What that is saying is it's the end result. So remember back when we had these, this is saying f of h of x represented this. This was the end result, and we started with two different functions. We're going to be given the end result and find what were the two original functions that they were before they were composed. So to do that, we want to show what that represents. So f, capital F, represents f of g. And let's start with the g of x function. So to do this, find your x input and look at one thing that's happening to it. So one thing that's happening to x is the square root. That means this, sorry, let's change that. The g of x could be the square root of x. So when we try to find f is what we started with, and g of x went into it. So f of x would be, let's say that square root of x took the place of our input, meaning it was just an x, and the square root of x went inside of it. And then we get f is x plus 1. And you can kind of check yourself as you're doing this to see what would it be if I put g inside of f. Hopefully you'll be able to see that this going inside of here would become square root of x plus 1. So these are our two original functions that we started with. Now we have another capital F, which represents f of g. So we want to start with g of x and see what could that have been. All right, so g of x, here's our x value, and we need one thing that's happening to it, at least one thing. So one thing is this plus 3. Our g of x could be x plus 3. Now f of x is what we start with and put g inside. So if g went inside of this, it needs to go inside on the denominator. So I have 1 over x. This is going into that function. All right. And the last one here, capital F, f of g of x. We're going to start with g and just find one thing that's happening. So one thing could be this x minus 1. So if g is x minus 1, that means that f would be 3 times this thing cubed minus 2. Since this went inside of here, that was the input, which is just x for now. There's multiple ways that you can solve these. So for the other two, we really saw just two main examples. But when we look at this, I said that you want to find at least one thing that's happening to x. So one thing that did happen was x minus 1. There is the case that g of x was x minus 1 cubed. And this is open, all right? There's not going to be just one answer, but there are multiple ways that you could get two different functions to give you this composition result. So if g of x was x minus 1 cubed, that means f is filling in the blanks of what that had. So it would be 3 times that thing. So 3 times that thing minus 2. That thing happens to have been an x because that's what we started with, and we're replacing x with g of x. And then we can do one more possible example. So g of x could have been not just x minus 1, not just x minus 1 cubed, but 3 times x minus 1 cubed. And if that was the case, then that's going inside of this thing. So that bubble, outer bubble, would be our x value. Minus 2 would be what's left over. Those definitely take a lot of practice to really truly understand this composition, but that's like the highest tier of what we'd be looking at. There are some examples in the lab manual for you to practice, so this would be good practice for you before you take the test.